All right, today we're pulling back the curtain on the hidden blueprint behind, well, basically every single piece of software you use. We're going to see how great ideas get transformed from just a spark of inspiration into these stable, reliable apps we all count on every day.
I mean, have you ever really thought about that? It kind of seems like magic, right? But here's the thing. There's a super structured, really intentional process that separates successful software from, digital dust. It's not just about some brilliant coder working away in a dark room. Because without a plan, you get exactly that, total chaos. Just imagine teams stepping all over each other's toes, features that just don't work, deadlines flying by, and budgets getting completely blown. It's a frustrating mess, and it always leads to buggy, unreliable products. So how in the world do professional teams avoid this digital disaster? Well, they have a way of turning that chaos into clean, functional code. The solution is a structured framework. It's a professional method that's designed to bring order, predictability, and most importantly, quality to what can be a really messy creative process. It's all about being intentional, right from the very start to the very end.
And that framework? Yeah, it's got a name. It is the essential blueprint that guides the entire journey of software creation. It's called the Software Development Lifecycle, or for short, the SDLC. Honestly, the best way to think of it is like the master recipe for a complex dish, or the architectural blueprint for a skyscraper. It's a series of repeatable steps that make sure everyone is on the same page and the project stays on track. So why do teams even bother with it? Well, an SDLC gives clear visibility to literally everyone involved, from the developers all the way to the business stakeholders. It helps manage risks, it helps predict costs and timelines, and, this is the big one, it ensures the final product is consistently high quality. Okay, so what does this blueprint actually look like? Let's take a walk through the fundamental phases that make up this whole life cycle. So it all starts with planning. That's where you figure out what to build. Then you move to design, which is how you're going to build it. Implementation, that's the fun part, the actual coding. Then comes testing, where you basically try to break everything you just built to make it stronger. Deployment is getting it out to the users. And finally, maintenance, where you keep it running smoothly and improve it over time. Now, these phases can feel a little abstract. I get it. So let's make it way more concrete. We're going to trace the journey of one single, pretty common feature, all the way from the initial request to a living, breathing reality. Let's use a classic example, an export reports button. Okay, so day 1, the request comes in, and the team plans it out. By day 3, designers have created the UI, what you see, and the technical plan for how it talks to the server, which is the API. A couple of days later, a developer gets in there and writes the code. Then the QA team just hammers on it with tests. Finally, it gets deployed carefully, maybe to a small group of users at first, and then to everybody, all while the team is gathering feedback for the next round of improvements. See? From chaos to code. Now, those phases we just talked about are the what, but the how you do them, that can change dramatically depending on the project. So let's look at the different paths a team can take. Yeah, there is no single, rigid, one-size-fits-all way to follow the SDLC. Different projects have totally different needs, and they require different approaches or models. The real key is picking the right recipe for what you're trying to cook. So the two most famous models you'll hear about are waterfall and agile. Waterfall is super linear. You have to finish one phase completely before you can even think about starting the next, just like a real waterfall. It's actually great for projects where you know the requirements are never, ever going to change. Agile, though, is the polar opposite. It is all about flexibility. You work in these small, rapid cycles, and you're constantly adapting to feedback. It's built for a world where change is pretty much guaranteed. And of course, there are a ton of other flavors out there. The iterative model builds the product piece by piece, in cycles. The V model is kind of like waterfall, but with a huge emphasis on testing at every single step. And then you have DevOps, which brings the development and operations teams together using automation to release updates way faster and more reliably than ever before. So choosing a model is one thing, but actually making it succeed in the real world, that really comes down to discipline and practice. The teams that absolutely nail this stuff have amazing habits. They define what success looks like clearly for every single feature. They automate all the repetitive tasks like testing and deployment.
They're constantly reviewing each other's code. They monitor the software after it's released, and they keep communication flowing. And this is a huge one. They build security in from the very beginning.
Now, on the flip side, projects fail when those good habits are ignored. Vague requirements? That just causes endless rework. Skipping tests means old bugs keep crawling back. A bad deployment with no way to roll it back can be an absolute catastrophe. And when teams don't talk to each other, problems are always discovered way, way too late. So here's the crucial point, the main takeaway. The software development lifecycle isn't some magic wand. It's a map. It provides direction, it provides structure, but getting to the destination successfully, that depends entirely on the team that's following it, on their discipline, their communication, and the path they choose to take. And, that brings us to a really fascinating final thought. For decades, this whole life cycle has been driven by humans. But as AI starts to write and test and maybe even design software itself, how is this fundamental blueprint for creation going to have to adapt for a completely new era? Something to think about. Thanks for tuning in.